Alright guys, you're welcome again to our Python tutorial series. Today we shall be looking at the inheritance in Python. Essentially what inheritance is, the concept behind inheritance is to help us to be able to make use of existing classes instead of reinventing the wheel. So if you have an existing class that encapsulates all the attributes and methods that we're interested in, we can just use that class as it is. And if we have additional attributes that we want to add, so we can just add it in our own specific class. So inheritance allows us to be able to create a specialized class from an existing class. So what happened in the child class which we're creating? So in the init method of the child class, we make a call, explicit call to the init method of the parent class. So like in this case, we have existing the class car. Now we have a special kind of car, which is electric car. So for us to be able to model a class for electric car, since it it has all the attributes and functions of any car, then we can just inherit the class car. Okay, so what we do here is we now have a class. We already have our class car, so which has these attributes and these functions. So for us to create the class electric car, we have a convention in Python. In the declaration of the electric car, you put two square bracket and you put the parent class in the bracket. Then in the init method of the child class, we do exactly the same thing that we have for the parent class. You see that it's exactly the same thing. But instead of we repeating all of this, what we just do is that we just use the super to be able to call the init method in the parent class. So we don't need to redo all those initialization again, but we still take all the values that are necessary to be able to instantiate the parent class, which is car in this case. So that's just that. So now after we have created the class, we can just do as we normally create our class, normally instantiate our class, call the class name and give it the init parameters. Then we reference it and we can use any of the methods that are inside the parent class. Here get descriptive name is actually defined in the parent class, so we can just use it and it just function well. So for us to be able to see a very good example of that, we now define an attribute inside the child class. So just like we have done before, now we are now defining additional attribute that we know is peculiar to the child class, to the class electric car, in this case the battery size. So we declare that attribute as a value, then we also declare a particular function that is peculiar to the child class, which is the describe battery, which essentially just gives us information about that battery size. So and once we call the electric car, you will see here that we give in the init required parameters, and by the time we now use the reference variable name to be able to call the get descriptive name, the get descriptive name, it's what we have in the parent class. This get descriptive name is in the parent class car. For us to be able to call its own defined method, we can just use the reference variable to directly call the the its own the child method that have been declared, the method have been declared in the child class, which is in the electric car. So let's see that in code. Alright, so here is our class car, which already has all the methods that we have looked at before and the attributes. Then we are now declaring our class electric car, and we are inheriting the car. And here, after we have made reference back to the parent class, then we are now declaring a special attribute for the class electric car and a special method for the class electric car. So it is essential we always first of all have this parent class before we have the child class. So we run the parent class first, then the child class, because we are inheriting from there. If not, we'll get an error. So here we are now creating a reference to the electric car, and we can get the descriptive name using the parent class. So this is a descriptive name. We just return what we have here, and the describe battery is in the electric car, which we just declare here, so we can just see that. So just give us the descriptive name normally as we have, and then we are able to get the describe battery, just like we see here. So just as another example, you can see again we can look at another example. So my Tesla 2, so we're declaring the variable for the electric car, and okay, always use, let's say it's BM Tesla, just look for a name for that. Okay, and the models, let's say BM22, and the year is 2020. Okay, so now we can now see that anytime we have this, we have a reference variable, and if you decide to print the this, it just gives us the information we normally have as before, because this is inheriting from our class car. So just give us the information that we normally have, like we have seen before. Now when we now use this to call the battery, describe battery, it will give us whatever information that we have declared inside the subclass, which is here. So here, what do? We just say whatever we are given it is just to print out the battery size. So it will just give us the battery size. But let's say I want to now change the battery size. So I have the battery size, so I reassign it to 90. Okay, so if I reassign the battery size to 90, so that changes the battery size, and I can get the size for us to see. So if I do that, you see it prints out the 90. So if I change this one again to 120, and by the time I print this, it changes it to 120. So all this, the battery size and the describe battery, the attribute and the method, are specific only to the electric car. That's what we're trying to say. It is just specific to the electric car. But aside that, we also have the opportunity of making use of the parent class car by just initializing instantiating our electric car class, our electric car object, using the same kind of attributes that is required of the parent class, and as a result we have access to all this information for the parent from the parent class. So for instance, I can, from my Tesla 2, I can access the odometer. I can say read the odometer reading. I can get that. So read odometer, that is that's a method. So I can read odometer and put that there, and it will just give me what the odometer reading is. I can access all the methods and attributes. So the odometer reading, I can access the odometer reading, that gives me 0. So all these are not defined in electric car, but then I can access, you can even see here, I can access all that is in the parent class. I can update the odometer, can update it, and that changes the value to 50. And by the time I print this again, and I want to find out what the odometer reading is now, so I can get the read the odometer meter, and that will be 50. Now I want this a method, so that will give me 50. So it says it is 50, because why? All these are available in the parent class, so we don't need to put all this information that we have in the parent class. All this, we don't need to redefine them inside here. No, by just inheriting the car, we have all those available for us for free, and that is the concept of inheritance. Thank you for listening. Do let us know what your comment are. You can give us a like if you benefited from this. Thank you. See you in the next one.